Hello everyone, welcome back to another video on the Education Always channel. Today we will be looking at the 3 states of matter. In this video we will cover solids, liquids and gases and changes of state. The kinetic particle theory of matter is a model that describes the arrangement, movement and energy of particles in a substance. The model is used to explain the physical properties of solids, liquids and gases. The table below shows a comparison of the same substance in 3 different states. A single particle does not have the properties of the material it is part of. The properties of a substance are the properties of a huge number of particles together. Solids have a fixed shape and cannot flow because their particles cannot move from place to place. They cannot be compressed because their particles are close together and have no space to move into. Liquids flow and take shape of their container because their particles can move around each other. They cannot be compressed because their particles are close together and have no space to move into. Gases flow and completely fill their container because their particles can move quickly in all directions. They can be compressed because their particles are far apart and have space to move into. The diagram summarizes the common changes of state. Some substances can change directly from solid to gas without becoming a liquid in between. This is called sublimation. Solid carbon dioxide, dry ice, can sublime. Energy must be transferred by heating for these changes of state to happen. During these changes, the particles gain energy which is used to break some of the bonds between particles during melting, overcome the remaining forces of attraction between particles during evaporating or boiling. In evaporation, particles leave a liquid from its surface only. In boiling, bubbles of gas form throughout the liquid. They rise to the surface and escape to the surroundings, forming gas. The amount of energy needed to change state from solid to liquid and from liquid to gas depends on the strength of the forces between the particles of a substance. The stronger the forces of attraction, the more energy is required. Every substance has its own melting point and boiling point. The stronger the forces between particles, the higher its melting and boiling points. The strength of the forces between particles depends on the particles involved. For example, the forces between ions in an ionic solid are stronger than those between molecules in water or hydrogen. This explains the melting and boiling point data in the table below. Evaporation can take place below the boiling point of a substance. Condensing and freezing. Energy is transferred from a substance to the surroundings when a substance condenses or freezes. This is because the forces of attraction between the particles get stronger. The state of a substance at a given temperature can be predicted if its melting point and boiling point are known. The table summarizes how to work this out. If the given temperature is smaller than the melting point, it's a solid. If it's between the melting and boiling points, it's a liquid. And if it's bigger than the boiling point, it's a gas. Limitations of the particle model. The particle model assumes that particles are solid spheres with no forces between them. However, particles are not solid since atoms are mostly empty space and many particles are not spherical. And that's it for today. Thank you everybody so much for watching. Please don't forget to like and subscribe for more. Any questions, pop them down below in the comments. Thank you. Bye.